Hi, I'm Walmsley and I'm presenting my first product, this little thing here, which is the rock by motor control board. Okay. So originally about a year ago I built a little robot which was done using a big truck, and a bigger version is made on prototyping board using strip board, and the robot works great.
We'll skip the other. Yeah, only another second.
So yeah, I literally created this robot. It's using the exact same method as this new board is doing, and I created a bit of JavaScript code which used Node.js on the Raspberry Pi and JavaScript on the web browser to be able to control the motors. And it was literally as simple as being able to press W, A, S or D on the computer, and then over the Wi-Fi it then transmitted it and worked. So this is the board, a bigger picture of the board. So you can see this was originally designed to work with an Arduino and a robot arm that me and my dad put together. So that's the bigger picture. So yes, this is the RTK-000-001 motor controller board, and it literally fits directly on top of your Raspberry Pi. You just screw in both the motors to the side port there. You can have one or two, and power to the bottom port here, and then literally it is a bit of Python program. So the information is that it's now on sale as a pre-order on Kindy. You get one PCB, one of the motor drivers, 3 of the screw terminal blocks, one Raspberry Pi pin header, 3 pin headers for the actual PCB which break out I2C, 3 volts and ground, and one 16-pin IC socket, so then if you blow the chip, you don't have to replace the whole board, you can just get another chip for it, which is about a couple of quid. And this is being sold for around £12.50, including P&P and everything. All you've got to do is buy soldering iron and put it together. So like I say, you can drive 2 DC motors in both directions without any extra wiring or anything added on top. It's designed to run between 4.5 and 12 volts, so 0.5 amps per motor, or 1 motor at 1 amp. You can increase this by stacking chips on top of each other basically, and also adding in heatsink. And you've got 2 pins for direct access to the GPIO and 1 squared C. Okay, so all I've done here is screw it together. All I've done here is screw in the power to the bottom here. Screwed in both of the motors on this, which are just normal cables. And then now when I get it booted up, sorry about that. And we can do some Python. Just got to wait for it to boot up. Oh yeah. Okay, now into Python. I've got to create this from scratch. Okay, so one of the best bits about this kit is that it's going to be very simple to be able to program. And I'm going to do that right here in under 5 minutes. So first off we have to import Python. So RPI GPIO, so it's import RPI GPIO as GPIO. Then we are going to do GPIO.setup. And we're going to set to the walk-on mode. I think that's right. Then we are going to go. Then we need to set the pin. Let's go here to get the chips.
and the pin reference?
You need just configuration reference.
What for Broadcom?
By tube, I reckon. Got it here.
Yeah. It's on there.
If you need an ISD card, it's got one of them as well.
Yeah.
Aha, that's it.
Got Dynascore as well. We're not having that.
This is a bit last minute as the port SD card corrupted before I got here, so as soon as I come to the thing. GPIO, and it's GPIO BCM. Okay, and then it is GPIO dot setup. Okay, this board is on pins 18 and 17 for the first motor, so that's one motor setup. And then motor 2 is on pins 22. And on 23. Okay, so that is basically the motor driver board configured to go. So it's literally pointing GPIO, setting up the 2 pins for both the motors, and that is it so far. And then to be able to output is GPIO dot output, and then to move forward we want number 17 to be high, and we'll then put that in a while step. And then to be able to run it, and this way it don't work.
You didn't let Charlotte touch it earlier, did you?
She's got nuts there.
Yeah.
Somebody else can play with it.
17 high, 22 high, I think.
Yes, that's it. And I'll put GPIOs up. We've got one motor moving. I spelled that a bit wrong. And this is where the network also flashes out. What's happening at the moment is the reason why that one's not moving is we accidentally turned on both pins at the same time, which means it does a full stop and it does it quicker than if you leave them both to low. So that's pretty good if you need to do so much stop straight away. That one's moving just by turning on 1 pin high. Both the motors support pulse width modulation. One of the motors is actually on the pulse width modulation pin, but they all work with software pulse width modulation. And that's pretty much it. It's a budget robot controller, which is pretty simple to program when your laptop works. That's it. Is there any questions about it?
Got half a minute.
Half a minute. No.
Any quick questions?
And you mentioned I2C. Does it do I2C as well?
It don't support I2C on the chipset, but it's just got basically 3 headers up here. You've got 2 which are, I think, ground in the middle, or 3 volts in the middle, ground's there, and you've got both I2 pins there, so then you can then plug on any I2 DC device on using pins externally if you want to be able to add in extra sensors. They don't have to be used as I2C, so you can use them just for GPI pins, but it's just that then you've got some interactive there. I chose I2 season, and if you did have an I2 module, you can use that. Okay, thank you.
Thank you very much.